Hi, I'm Christina Giannaloni, and I am here to present the Blink Labs F13 closeout video for Cloud Native Blockchain Archive Node by Blink Labs. Project number right here, and you can see that this project was funded through the Cardano Open Developers Challenge. We entered this challenge because Blink Labs builds open source infrastructure for Cardano, and this proposal aligned directly with the challenge goal of improving developer tooling and making Cardano infra easier to run, extend, and integrate. Our proposal focused on making Cardano archive node infrastructure more modular and cloud native. And you can see that we requested 118,660,000 ADA. And we got on here, there's a little more detail. But to summarize it, the problem we're addressing is that archive node workflows can be expensive, rigid, and operationally difficult. We wanted to make it easier for devs and operators to use different storage backends and deployment patterns without requiring custom one-off infra. The goal was to create reusable archive node building blocks that fit cleanly into existing Go and Cardano infrastructure workflows. So we manage our projects using a public GitHub project board. You can see we have milestones, we have linked pull requests, we do code reviews, and there's evidence for testing when applicable. All this stuff is open to the public, so anybody can take a look at it. We delivered this project through 4 milestones. So in milestone 1, we decoupled core storage interface from the node logic. This created the foundation for backend portability and future archive node expansion. In milestone 2, we implemented the PostgreSQL metadata backend and added a Google Cloud storage support. This gave operators a production capable relational metadata option paired with cloud object storage. We go down to milestone 3. We added MySQL metadata backend and Amazon S3 support. This expanded the archive node approach across another common relational database and another major cloud provider. And if we go down to milestone 4, we delivered immutable data pruning and transparency data proxying. This enables a paired archive node model where non-archive nodes can prune local immutable storage while still retrieving historical data through an archive or proxy path. So these milestones completed the intended architecture: modular storage, configurable deployment paths, cloud object storage support, and archive access without requiring every node to keep all historical data locally. So let's see. We can go ahead and look at an individual one. I had gone ahead and pulled up the implement key value interface over Google Cloud Storage. And really what I want to show you is you can scroll down and you can see all the pull requests to accomplish this goal. And if we look at the pull request, you can see the exact detail of what was done. You can see the back and forth from our developers. We do have developers approving these pull requests. Nothing's just pushed directly to prod. And this, I think, makes the closeout process easier for anybody to audit because the evidence is tied directly to issues, pull requests, and milestone deliverables. The implementation is open source and available for any dev or operator who wants to inspect it, run it, or build on this archive node. So go back here. The project stayed within its funded technical scope. The main challenge was delivering infrastructure grade code in a way that remained modular and provider agnostic while still being practical for real deployment environments. What we didn't do was turn this into a polished end user product. This is infrastructure work. So the value is in the reusable backend components, the archive node architecture, and operational patterns that other tools and services can build on. So what exists now is a more modular, provider agnostic archive node foundation with support for PostgreSQL, MySQL, Google Cloud Storage, and Amazon S3, immutable data pruning, and transparent data proxying. So this benefits devs and operators by reducing the need for custom infrastructure, making archive workflows more flexible, creating building blocks that can be reused across the Blink Lab stack and the broader Cardano ecosystem. So, next step in the project is really just continuing operational hardening, performance, and stability tuning. We really appreciate the Catalyst funding that made this work possible, and we continue to build on these outputs as part of our open source Cardano infrastructure work. Next, I will show you a video that demonstrates this so you can see for yourself. And of course, I've got a little QR code if you want to go directly to the repo and actually execute this yourself. Thanks so much.